Our next question is titled, why does this thing call a thing that calls a thing? And I want to talk to you a little bit about how we build compositional units in the shell. I want to talk about shell scripts, aliases, and functions, common patterns and compositional approaches that come up. But unfortunately, we won't have an opportunity to talk about things like structuring interactive or semi-interactive programs, which is a very complex topic, or some of the more advanced compositional approaches that might come up, or some of the rules of things like substitution and redirection. Here, let me show you a very simple program. And it's to simulate maybe a program that one of your colleagues work, one of your coworkers wrote. It has an argument parser, and it takes files, a flag, and some mode, and it just prints them to the screen, because it doesn't really need to do anything for the purposes of this example. So if we look at this program, we can see, okay, it takes a bunch of file names, and it has a mode. So I guess it's like doing some sort of machine learning with some file names as the training data in either our production environment, our dev environment, our QA environment, and there's a flag, and I don't know what that flag does. Maybe if you set the flag, then it writes to somewhere, or it doesn't write to somewhere, or maybe it changes some modality somewhere deep within this. You use this tool all the time. And you pass in these arguments every time you're using it. You're probably using it interactively, A, B, C, D, flag, mode, QA. And you say to your coworker who wrote it, thank you for writing this tool for me. I use this all the time. And one thing that you can see that's kind of interesting is, for that argument parser, you can pass the arguments in any order, which is kind of useful. And if you happen to wonder, is that a general thing that I can rely on? For a lot of the GNU user land, for a lot of the standard tools that you use, it is something you can rely on. One pro tip that I would love to share with you is this. Let's say you have a bunch of files, 1, 2, 1, 2, 1, 2, in directories A, B, and C. And you want to delete those directories. Well, you need to do the recursive deletion to delete a directory using RM. And maybe you might want to even force that. If you write this, and you're writing A, B, and then you slip, and then press enter, you might have deleted your root directory. Now, of course, in RM, you have to do no preserve root to really force it to do that. But you can imagine that you could easily slip halfway through and do something you're not supposed to. Instead, because that RF can come at the end, what you could do is you could say, remove everything, remove the A, remove the B, and if you slip and fall, it's not going to do anything. You can remove the C, you can take a deep breath and say, okay, now I'm ready, RF. You can place these arguments at the end. Being able to do that helps you significantly, because imagine when you're at the command line, what do? You write a command, you press up to go to the previous command, you kind of edit this thing, you kind of move back and forth. Being able to put these arguments towards the end is very, very useful, because if that happens to be the flag that changes a lot, or if that happens to be a dangerous flag, you can wait to put it at the end, or you can just have all the churn and the different variations of this command line run happen at that very last portion. Now, let's say that you run this command all the time. And just to show you that I run it all the time, you even put the directory where it's stored in your path, so you don't have to do the // you just have to run this. What if you always run it with the QA flag? That's just your standard. You just always use the QA flag. You are so scared to touch the production environment, and the dev environment is used by like the software programmer types, and you really don't want to mess with them. They're very mean. You're a data scientist. Stick with your own data scientists. They'll be a lot nicer to you. You want to kind of hard code that QA, or at least make it a little bit harder for you to do anything else, just so you don't accidentally do something in production, or you don't accidentally, upset the mean software programmers. What you might do is you might alias these. And when you alias this, you can see that when you run the program, your shell will substitute this invocation of prog with the invocation that you have here. There are a bunch of aliases that you probably use every day and you don't even know. On almost every shell, ls, to list files and directories, is aliased. It's almost always the case that it's aliased to something, just by default, or just in some corner of your bash RC or zshell RC that you copied from somebody 17 years ago when you were in grad school and you were first using the command line. It is the case, however, that this alias will not be invoked if you happen to use a // if you happen to use a full path. So the alias is really just looking for the name of the command appearing at the very beginning. If you do something like echo prog, well, it's not going to replace the alias here. Although in some shells, like Z shell, you can actually have global aliases. So here, this is a regular alias. This will only appear in use. So this will only do a substitution if ABC begins at the beginning of the line. But with the global alias, it'll actually replace every unquoted single instance of ABC. Now that is a very dangerous thing to do, because imagine how you could have a file name and you say, I don't know, don't use this file, use other file name, and then drive yourself absolutely nuts until you realize that you had an alias in place that was replacing these things. In general, I basically don't use anything except the built-in aliases. It's so limited, and it doesn't really add that much to my life. The built-in ones give me, how often do I want to always run with specifically only these arguments, but I never want to change them? Not enough. I know some people who use a lot of aliases because they have some flags for formatting that they really always want to use, like always turn on coloring, always turn on paging, and things like that. But for the most part, I actually minimally use aliases. Another option, if you didn't want to use an alias, is you could write a shell function. So here I have 3 shell functions, and maybe now we're in an environment where the software programmers are actually quite pleasant, quite nice people, and as a consequence, we're free to run in the dev environment, and maybe we have a stealth startup and we don't really have any customers yet, so I can even run in the production environment. That's fine too. So I have 3 shell functions. Prog running in prod, prog running in QA, prog running in dev, and each one of these I hard code maybe some relevant options, like in the QA and the dev I use that flag option, in the prod I don't use that flag option. And you can see I can run these, and from the perspective of what this looks like when I'm doing this interactively or from a script, you can't really tell that this isn't a standard binary. You can't tell that this is a function. What you can think is inside this function, I could do all sorts of switching. I could take extra arguments that don't exist on the underlying program. I could say, maybe I could require that they do -- really or -- I mean it whenever they run the prod version of this, and you check here, if the first argument that's passed in isn't really, then you bail out and you say, did you really want to do that? Something like that. And you can think you can add some programmatic behavior just to make your life easier. I typically use functions where other people would use aliases, because what I discovered is what's more useful isn't just aliasing what the name of the program is. What's more useful is providing a cut down set of options and then filling them in. Because one of the things you can think is you could add new supplementary options, which then trigger actual options. That's a very common thing, right? So instead of prog, prod, really, I mean it, being the actual options, that then translates into the actual options for the underlying program. Another thing you could do is you could write a shell script. But I want to show you one more thing about writing a shell function. Here, if I write this shell function and both the script, which doesn't matter what it does, and the function both exist, where the shell script is in the path and the function is here, well, what actually happens when I type prog? Well, depending on your shell, usually one of these must take precedence, and usually it's the case that the function takes precedence. So when I type prog, even though there's 2 things named prog, the shell function and the shell script, the standalone script, the function will take precedence. This is why you might see people don't use which, or they use user bin which, or they use bin which, they don't use the shell built-in which, or they'll use command-v, because some of these allow you to look for an executable in the path that's named what you're looking for, ignoring possible shell functions, which might alias things. Aliases, if I do prog, QA, and you'll see how aliases also behave. If you have all 3 of them, you'll see that which here will tell you which of these you use. Are you using the alias, are you using the function, are you using the actual binary, or the actual script on disk? Whereas command-v can say, oh, you know what, ignore that other stuff. Just tell me where the thing is on disk. You can even do it with the -p flag, which tells you don't use the user's customized path, use the default search path. But that's always kind of tricky. Like, where does that actually get set? It's in the etc directory in like etc profile or something. But if you found the thing, then you could use something like readlink to find what the authoritative, actual absolute path to the underlying program is. If you wanted to, instead of writing a shell script, you could instead of writing a shell function, you could write another script. But in the shell function and the script, you have the same problem, which is, what if you need to invoke the original program? And how do you make sure that you don't recursively just re-invoke yourself, because that's what's your path? Well, in the case of a function, it's pretty straightforward. What you can do is you can use Command V to be sure you're looking for a file on disk that's run, not another alias, not another function, and just find where the location of that is and then invoke that. If it's the case that you have two scripts, one in, say, the bin directory up here, and this is the actual script you want to run, and something in the scripts directory, which is your front end for this. And in this front end, you can do any sort of crazy stuff that you want to do. Add extra arguments, infer other arguments, hard code arguments, look at a special .rc file that you created just for yourself, for your specific, host-specific options, whatever the case may be. How do you make sure this doesn't run recursively? Because if I run this, this is going to recursively invoke itself. And that's going to be a problem. And you can see it kind of jams up my output by running itself recursively. Well, that's a little trickier. And this is one reason why you might want to write a shell function rather than another script. Because if you write another shell script, it can sometimes be difficult to find that shell script using the simple trick like Command V. But there is a way. And there's a couple of different ways. One way you can do that is you could have your wrapper figure out what its current directory is. This is how you do it in Z shell. You ask for what the program that was invoked. And there's a controversy going on right now about what happens when a program is not given its argv0 and whether that's valid or not. But usually, in most cases, you'll get one that's the program name that's invoked. You can figure out what that program actually is by looking at the absolute path. You can look at the directory it's in. You can remove that from your path. Or a trick that we'll talk about when we talk about containerization is you can have BWrap create a synthetic environment where you mount the directory where that thing is in as a temporary directory. So you clear out everything, and then you ask, wait, this directory doesn't exist anymore. Which prog are you looking for? And then use that to invoke. So there are these approaches if you have multiple layers of shell scripts. But if you do happen to have multiple layers of shell scripts, do always make sure that if they're named the same thing, you're always calling one by either absolute path that you know ahead of time, or you're not accidentally recursively invoking yourself, because that's a problem that I know I've had run into enough times, and I'm just like, wait, I keep typing this command, it's not doing anything. My memory keeps getting larger and larger, and my computer is really slowing down. Something's going on, and it's actually just recursively re-invoking itself. Now, I want to show you one other pattern before we wrap this up. One thing to think about when you're writing shell functions or shell scripts is really trying to identify what is your program doing, whether it's in a function or a shell script. Is it operating interactively, or is it operating non-interactively? Interactively is like a Python interpreter or a PSQL interpreter or something like that. That is a very large topic. They are very complex to write. Sometimes they can be even as complex as full graphical user interfaces, and so we'll leave that off to the side. If they are operating non-interactively, there's another dichotomy here. A non-interactive program could be said to have stateful dependencies, or it could be said to have no stateful dependencies. And I'll give you an example of either one. Stateful dependencies would be a program which does something, then looks around to see what the state of the world is, then does something else, and looks around to see what the state of the world is, and does something else. An example of that might be a workflow system like make. It builds something, then maybe checks to see that thing's built, and then builds the next thing, checks to see if it's built, and then builds the next thing. If it somewhere fails along the way, it stops running. A program that has no stateful dependencies is just something which is a combination of commands that run. Maybe there's a modality there that's determined by the input, but because the core of that script is stateless, it never has to see the outside of the world and never has to interact with the outside of the world. And also, given the input, you can predetermine what commands it's going to run because none of the commands rely on some previous state. And that actually is a pretty often thing that comes up, right? I want to run these commands in this order. Maybe, at most, I want to terminate if one of them fails. But beyond that, if I'm creating a new user account, I want to create their home directory. I want to use user mod to add them to groups. And yeah, if something fails, maybe I want to terminate. But for the most part, I'm just doing command sequentially. I don't really care to look around to see if they succeeded or not. If you happen to have non-stateful, non-interactive programs, I want to show you a very useful pattern. I write these kind of programs all the time. Because you read some tutorial and it's like, oh, here's a new library. It's so easy to use. Run 3 commands every time you want to do something. I'm just like, I don't have time to run 3 commands. Let me get one little script that does all 3 of those in a row. Well, oftentimes, when you have these programs, even though they're non-interactive, you're still running them in an attended session, and you still want to see what they did if they broke. You want to see what steps they ran through. You want to have like a dry run mode. And one thing you could do in any script that you write is you could add a dry run mode. And the dry run mode says, oh, don't actually execute it. Just tell me what you would do. But another approach you could do is don't have the script actually do any work. Instead, have the script construct the arguments or construct the command line commands that it's going to run and just print them to the screen. And so here, this is a script that constructs a Z-shell array that contains a bunch of symlink commands. And it doesn't run those commands. It just prints them to the screen. So I start with these 4 files, and if I run my script, it didn't do any work. It just printed those commands to the screen. Are those the commands I really wanted to run? Okay, that looks good. And when I tell myself, oh, that looks good, then I can pipe that to my Z shell and actually run them. So I get a dry run mode for free. And I have a bunch of different ways that I can go about doing this, and there's some caveats, some qualifications for which of these are maybe the better or worse ways to do this, but I could do like that. And if I wanted to see them at the same time, I could use T with process redirection, and now I can see, oh, it did this, and it actually goes and it executes them. That's very useful. And if I needed to, in a pinch, ad hoc manipulate this, I could store these commands to a file, then hand edit that, or just do some simple things like, you know what, something's going wrong whenever the file has a B in the name, just remove that. Or just only, do this, do a grep inverse, remove that, only do the A, C, and D. So I do this very often. I have a script, and all it does is it prints commands to the screen, which then I can then further manipulate or store to a file and manipulate by hand, and then I can invoke them. In fact, a very, very common pattern that I have, and this is a super, super, super pro tip. I will often need to rename lots and lots of files. And what I'll do is I'll enter an interactive editor session, and let's say I have files named, let's just pretend I have files named 1 to 10. I'll enter an interactive session. I'll take these file names. I'll use my really fast interactive manipulation. Look how fast I put a .py on the end. Then I'll use a very, very simple Vim thing that I have that just interleaves these. Oh my goodness, I'm just about to rename 10 files with a py, and also if there's some small difference in these, I can immediately deal with this. Do that, eyeball it. Does that look good? It does. And then have my editor write this to a Z shell process and execute them. There are a million file renamers out there. They are so complex. The vocabulary that you need to use in order to specify what part you do what in is just so enormously complex, and I don't understand why they exist because you know what? Why bother? Just construct it with all of your handy-dandy editing stuff and have your editor pipe the output to your process, and you go and do that. And this gives me the ability to both have automation, ad hoc automation that I created just right there on the spot, custom to the thing that I'm doing, and to have as many corner cases because I have the perfect mix of automation and just enough leeway for a human being to say, oh, you know what? I don't want to touch this file, and this file should be 6.5.py. You would be shocked at how fast I can rename big, big collections of files with this simple, stupid approach, just Vim macros and piping this thing to my shell process.